different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is not equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Kokra and Walton in 1932 experiment.
Albert Einstein was born May 14th, 1879, and today is known as one of the world's biggest scientists and famous in the whole world. And so the question is, where did he begin? Well, in 1901, he got sort of almost like an offer. Einstein became a big figure and is an extraordinary professor. After World War, Einstein became a huge professor, a big name, and then so fast forwarding to 1948, he and Dr. Chaim Weizmann collaborated, and believe it or not, Albert Einstein was offered presidency of the state of Israel, and they helped establish a university, Hebrew University of Journalism. Albert Einstein eventually got to working on Newton machines, and yeah, so and Albert had a theory that, and this is a quote. He says, "Of relativity stemmed from an attempt to reconcile the laws of machines with the laws of experimental field. He had to deal with some problems in the process, but he had thought of a quantum theory, which explains the movement of molecules. And so Einstein eventually also studied the properties of light. And his observations led to the photon theory of light. So we're going to get a little more into his early careers and stuff that he's done. So first of all, when he was 16, he imagined chasing a beam of light and thought that the experiment could play an important role in special relativity. And so that was very interesting. And so also, Albert Einstein got, in the very beginning in 1896, Albert entered the Swiss Federal Platonic School and did train to be a teacher of physics and mathematics. And in 1905, Albert Einstein got a doctor's degree. So this next experiment thing that Albert Einstein conducted that we're talking about is his thought process about lightning strikes a moving train, May 1905. Now, in this experiment, Einstein thought that observers of this experiment can experience something differently at the same time. So, he has said before that it's perfectly possible for two events to simultaneously happen from the same perspective in the observer. Yet, this will happen at different times from both observers, and their perspectives would be different. So basically, okay. And so it was very, interesting, and, okay. Now basically, he thought, imagine at first you have an observer overlooking a train roaring by. Then, all of a sudden, they're in awful trouble. The train gets hit by a lightning strike. Just at the train's midpoint, the lightning bolt strikes. And the observer must be panicked because he was right next to that train. It flashes next to the observer's eye. And, so now there is another observer sitting on the train the moment of the midpoint where the bolt hits. The light to her traveled equal distances. The train keeps on moving, heading toward the continuing flashes of light, and she could eventually only conclude that the lightning strikes were not simultaneous, and then realize what simulation happens on what's related. So after that, Einstein dashed to making papers and titled them on the electrodynamics of moving bodies. And so he conducted another experiment during September 1905, mass and energy. And so throughout the whole summer of 1905, he was obsessed with relativity and published a second paper on this topic during September of 1905. The paper was about imagining an object sitting at rest, and so get a good picture about an object sitting at rest. And okay, imagine that it simultaneously creates or emits pulses of light. Alright, so the object just stayed there, and the object decreases because of a pulse that carries a certain amount of energy. And now what would look like to an observer? Well, to her or him, the object would just stay in a straight line, while two pulses of light flew off. But even the two pulses would be the same because of the speed of light. Their energies would be different, but the pulse moving forward along the direction of motion would have a higher energy than the one moving backwards. So yeah, Einstein concluded with the equation E equals mc2, and that kind of became, I gotta say, a more famous equation. And so now we're going to move later in time when this whole atomic bomb kind of thing happened. When the country was at war with each other. And,
Ladies and gentlemen,
and what Albert Einstein thought of the Germans.
To present to you on this auspicious occasion the world-renowned theoretical physicist whose original work, more than that of any other living scientist, led to the discovery and development of atomic energy. Fortunately, the world's greatest living scientist is also the kind of a person who has as much of a social conscience as he has scientific insight and vision. In presenting him to you this evening, therefore, from his simple American home here in Princeton, I give you not merely a great scientist, but the equally as great citizen of the world, Dr. Albert Einstein.
Ladies and gentlemen, the conversation I had with 3 students of your university has made a strong impression on me. It showed me that a sense of responsibility and initiative is at work in the young generation of this country. These students are aware of the fact that the destiny of the new generation will be decided in these few years. They are determined to influence the pace of events within the framework of their possibilities. What is the situation? The development of technology and of the implements of war has brought about something akin to a shrinking of our planet. Economic interlinking has made the destinies of nations interdependent to a degree far greater than in previous years. The available weapons of destruction are of a kind such that no place on earth is safeguarded against certain total destruction. The only hope for protection lies in the securing of peace in a supranational way. A world government must be created which is able to solve conflicts between nations by judicial decision. This government must be based on a clear-cut constitution which is approved by the government and the nation, and which gives it the sole disposition of offensive weapons. A person or a nation can be considered peace-loving only if it is ready to cede its military force to the international authorities and to renounce every attempt or even the means of achieving its interests abroad by the use of force. It is apparent that the development of the political relations in the year which has elapsed since the conclusion of the Second World War has brought us in no way nearer to the achievement of this goal. The UN, as it stands today, has neither the military force nor the legal basis to bring about a state of international security, nor does it take account of the actual distribution of power. Real power is at present in the hands of a few nations. It is no exaggeration to say that the solution of the real problem is linked solely to an agreement on a grand scale between this country and Russia. 4.
That was Albert Einstein talking about nuclear weapons and world governments. And that was, of course, just half the video. But if I did that all day, my hand would get really tired. But anyways, I'm sorry. So when I just want to discuss when Albert Einstein died. That day was sad. I mean, you are losing someone who is like the world's most famous scientist and is just incredible and he's such a good scientist. It was sad to lose him. I mean, that guy, he was amazing. Completely amazing, that guy.